Hello, viewers. In today's session, we are going to discuss an important and conceptual problem from domain of functions, right? And in this class, we'll solve this problem in which we have to find the domain of this function f of x involving the inverse trigonometric functions, right? So here we have f of x is equal to tan inverse square root of x divided by sine inverse x minus 1, right? So here we'll see how we can find out the domain of functions by using the concept of intersection of domains, right? So let us start. So here we have the quotient of two functions, right? Tan inverse square root of x and sine inverse x minus 1. So let us first see the domain of tan inverse square root of x. So here we have tan inverse of square root of x, right? Now see, from inverse trigonometric functions, we know that the domain of tan inverse theta is the set of all real numbers. That is, theta belongs to the set of real numbers. So whenever we have tan inverse theta, then theta takes all the real numbers. Now here we have for theta we have square root of x, right? And since here we have the square root of x, so the this quantity x has to be greater than 0, right? Because x cannot be negative here, because when we have a negative quantity inside the square root sign, then we have a complex number. So here the domain of tan inverse square root of x is x greater than 0 or equal to 0, right? So here x can take all the positive values or the positive real numbers, including x is equal to 0. So the domain of tan inverse square root of x is given by x greater than or equal to 0, which can also be written as x belonging to the set that is 0 to infinity, right? Okay, now let us come to sine inverse x minus 1. Now let us consider the function that is sine inverse theta. Now, when we have sine inverse theta, then this theta must belong to the interval that is minus 1 to 1. That is, theta must be greater than or equal to minus 1, but it is less than or equal to 1. So here for theta we have x minus 1. So let us substitute theta is equal to x minus 1 in this inequality. So we have minus 1, and here we have x minus 1, and here we have 1. So now solving this inequality by adding plus 1 throughout this inequality. So we have plus 1 minus 1. Here we have plus 1 plus x minus 1. And here we have plus 1 plus 1, right? So here 1 minus 1 is 0. And here we have 1 and 1 get cancelled. So we have x, and here we have 1 plus 1, 2, right? So we have this inequality, right? And here there is one important thing to note. See, sine inverse x minus 1, it appears in the denominator. And whenever x is equal to 1 or x minus 1 is equal to 0, then we have sine inverse 0 is equal to 0, and we have a 0 in the denominator. And in that case, the function f of x is not defined, right? So apart from this inequality, this sine inverse x minus 1 should not be equal to 0, right? So for this, x should not be equal to 1. So incorporating these two, the domain of sine inverse x minus 1, which appears in the denominator of this function f of x, we have x greater than or equal to 0 but less than or equal to 2, including x is not equal to 1. So now let us call the domain of tan inverse square root of x as d1, and the domain of sine inverse x minus 1, which is given by these two expressions, let us call it d2. So the overall domain of the function f of x is given by, say, d is the domain of f of x. So D is given by the common region between D1 and D2. So we have the intersection of D1 and D2. So to identify the common domain, we have to take help of the real number line. So let us draw the real number line like this. So here we have minus infinity, here we have plus infinity, and let us take here the point 0, and then we have 1, here we have 1, then let us take here the point 2. So now the domain D1 is given by x greater than or equal to 0, right? So we have this region, that is x greater than or equal to 0 is given by this region. So here this 0 is included. So here we make it dark, and then we have x greater than or equal to 0 but less than or equal to 2, right? So we have like this, and from 0 to 2, and here we have 1, right? And 1 is not included, so we'll make a circle here. So this circle indicates that this x is equal to 1 is not included, right? And here both 0 and 2 are included. So now the domain D is given by D1 intersection D2. So D1 is x greater than or equal to 0. It means D1 is given by this interval, that is 0 to infinity. So here 0 is included, right? And then we have the intersection, and then we have D2. So D2 is from 0 to 2. So first we'll write here 0 to 1. So 0 is included but 1 is not included, so here it is open, right? And then we have union, and then here we have 1 to 2, right? 1 to 2, and 2 is included, so here we have a closed interval, right? So D1 intersection D2 is given by this notation. So now the common region between these two domains, this is D1 and this is D2. So here the common domain is this region, right? From here to here. So from 0 to 2, we have the domain of f of x, excluding this x is equal to 1, right? So the intersection of these two intervals is now given by this one, that is 0 to 1, and here 1 is not included, and then we have the union, and here we have 1 to 2, and 2 is closed. So the domain of this function f of x is given by 0 to 1, from 0 to 1. 1 is not included, 0 to 1, 0 is included, and then from 1 to 2. From 1 to 2, 1 is not included, and here 2 is included. So the domain of f of x is given by the union of these two intervals. So we can also express this notation like this. We can take the entire interval from 0 to 2, that is 0 to 2, and then we can exclude 1 from this interval, right? So we can also write here 1 in the curly brackets. Hello viewers, in today's session we are going to discuss another important problem from domain of functions. And here we have to find out the domain of this function f of x, which is equal to square root of x minus 2 plus 1 over x minus 3. Right? So here f of x is given as a sum of two functions. Right? So let us call this square root function as g of x, and this is a rational function, and we can call it as h of x, right? So f of x is the sum of square root function and a rational function. So in order to get the domain of this function f of x, what we will do, we'll first find out the domain of this function, that is square root of x minus 2. So let us call the domain of this function as d1, and then we'll find out the domain of this function, that is the rational function 1 over x minus 3, and let us call the domain of this function as d2. And then we'll find out, or we'll identify the common values of x which simultaneously satisfy this function f of x, and those common values of x are known as the domain of this function f of x, right? So let us call the domain of f of x as d. So d can be written as d1 intersection d2. So let us first individually find out the domain of the function x minus 2 and 1 over x minus 3. So now the function square root of x minus 2 is valid only when x minus 2 is either greater than 0 or equal to 0, right? So x minus 2 has to be positive or 0 in order to define this function g of x. Because if x minus 2 is negative, then this expression becomes a negative expression inside the square root sign, and in that case we'll get a complex number, and in that case the square root of a negative number does not belong to the set of real numbers, right? So for the validity of square root of x minus 2, this x minus 2 should be greater than or equal to 0. In other words, we can say that x should be greater than or equal to 2, right? So the domain of square root of x minus 2 is given by x greater than or equal to 2, which can also be written like this, that is 2 to infinity, right? So here this 2 is closed, it means 2 is included here. Now let us take up this rational function 1 over x minus 3, and here we are calling this as a rational function because a rational function is defined as the quotient of two polynomials, say p of x and q of x. So here one is p of x and x minus 3 is q of x, right? So the domain of this function is all real numbers except 3, because when we take x is equal to 3, then in the denominator we'll get 0, so this becomes 1 over 0, which is not defined, right? So the domain of this rational function is given by the set of all real numbers except 3, right? So now we have obtained the domain d1 and d2. So let us find out the intersection of d1 and d2 by making use of the concept of a real number line. So here we have the real number line, and this is minus infinity, and here we have plus infinity, right? So let us plot the points 2 and 3, and here we have 2 and here we have 3. So let us first represent d1. So d1 is from 2 to infinity. So we'll go like this. So this is the region which represents d1. So this is the domain d1, and remember here this 2 is included, right? Okay, now let us represent this domain d2. So d2 is r minus 3. So here we have the entire real number line, except here will not include 3, right? So first we'll go from minus infinity to 0, and then sorry, here we'll go from minus infinity to 3, and then from 3 to infinity. So this interval, or r minus 3, can also be written as minus infinity to 3 and union 3 to infinity, right? So here this circle signifies that 3 is not included, right? So here this 3 and this 3, they are not included. Okay, so now from d1 and d2, here we have d2, we have to now identify the common region, right? And from this real number line and the domains d1 and d2, we can easily identify the common region. So now the common region comprises of the interval that is from 2 to 3. First we'll go from this point, that is 2 to 3, right? 2 is included and 3 is not included, right? And this reason, that is minus infinity to 2, is not included in d1, right? So we'll leave it, and then we'll take this interval that is from 2 to 3. 2 is included and 3 is excluded, right? Because here 3 will make x minus 3 0, and 1 over 0 is not defined, right? And then we'll have here the union, and then we go from 3 to infinity. So then here we have the open interval. It implies that 3 is not included. So we'll go from 3 to infinity, right? So the intersection of d1 and d2 is given by this the union of these two intervals, right? So we can also write this expression in a compact form, that is we can go straight away from 2 from 2 to infinity, and then we can write here a negative sign, and then we can exclude 3, right? Because 3 appears between 2 and infinity. So the domain of this function f of x is given by either this interval or this one.